This video is on trigonometric identities. The quotient identities are tangent of theta is equal to sine theta divided by cosine theta. Cotangent theta is equal to cosine theta over sine theta. So these are just flipped, and these are important, so you will want to make sure you have them written down or you know them. All right, reciprocal identities. So sine and cosecant are reciprocals. So sine theta equals 1 over cosecant theta, and cosecant theta equals 1 over sine theta. Same thing with cosine and secant. Cosine theta equals 1 over secant theta, so secant theta equals 1 over cosine theta. Then we have the same thing with tangent and cotangent. Tangent theta equals 1 over cotangent theta, and cotangent theta equals 1 over tangent theta. All right, we also have Pythagorean identities. Okay, and these are going to be the last of the identities that we're going to use for this lesson. So, cosine squared theta plus sine squared theta is equal to 1. Tangent squared theta plus 1 is equal to secant squared theta. Cotangent squared theta plus 1 is equal to cosecant squared theta. So these again are really important. The last part is just to look at where cosine theta and sine theta are positive or negative. So remember, cosine theta is the x value. If we're looking at the unit circle, sine theta would be the y value. So when we're looking at the unit circle, if we divide it up, we can think of it as quadrants. So from 0 degrees to 90 degrees, both x and y are both positive in this quadrant. So cosine theta and sine theta are both positive. From 90 degrees to 180 degrees, the x value is negative, meaning cosine theta is negative. Y value is positive over here, so sine theta is positive. From 180 degrees to 270 degrees, both x and y are negative, so both cosine theta and sine theta are negative. And the last one, just think of it as a quadrant. We have 270 degrees to 360 degrees. The x values are positive, so cosine theta is positive. Y values are negative, so sine theta is negative. And this will be important when we're working with them. So let's go through some problems. So we're going to find the exact value of each expression if theta is greater than 0 degrees and less than 90 degrees. And in this, I know in this first quadrant that both cosine theta and sine theta are both positive. So I don't have to worry about figuring out if the answer is going to be negative or not because, well, they're both positive. So if cosine theta equals 1/5, I need to find sine theta. So for this one, I'm going to start with my Pythagorean theorem or Pythagorean identity. And I'm going to use the one that involves both cosine and sine. So cosine squared theta plus sine squared theta is equal to 1. I'm going to plug in what I know. I know cosine theta is 1/5. But this is cosine squared theta, so I have to write 1/5 squared plus sine squared theta is equal to 1. Right, when I'm squaring 1/5, I square the top, square the bottom. 1 squared is 1, over 5 squared is 25, plus sine squared theta equals 1. I want to get sine theta by itself, so I'm going to subtract 1/25 on both sides. Those cancel each other out. I'm going to move my problem up here. And I have sine squared theta is equal to 1 minus 1/25 is 24/25. Okay, I want to know what just sine theta is, not sine squared theta. So opposite of squaring something is taking the square root. I'm going to take the square root of both sides. So squaring and square root are opposites, so they cancel each other out, and I'm left with just sine theta equals square root of 24 over the square root of 25. So I have to look at what is square root of 24. So I have to break this down. 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. Meaning, we have a pair of 2's that can be pulled out. And I'm left with 2 times 3, which remultiplies to 6. So, because we're taking the square root, it's either positive or negative. Square root of 24 is 2 square roots of 6 over square root of 25 is 5. All right, so I said in this first quadrant, sine, which is my x value, is positive. So I know the answer is going to be positive. If it had been in one of my other quadrants where sine was negative, I would have to pick the negative value. So my answer, sine theta, is equal to positive 2 square roots of 6 over 5. Okay, so we're going to stay in that same quadrant. We're going to try another one. All right, if sine theta equals 2/3, find secant theta. I'm going to use the same Pythagorean identity. Cosine squared theta plus sine squared theta is equal to 1. I'm going to plug in 2/3 for sine. So I have cosine squared theta plus 2/3 squared, because I have to remember there's a squared here, is equal to 1. So I have cosine squared theta plus 2 squared is 4 over 3 squared is 9. It's equal to 1. I want to get cosine by itself, so I'm going to subtract 4/9 on both sides. And I'm just going to move my problem up. I get cosine squared theta is equal to 1 minus 4/9 gives me 5/9. Okay. Here I have to take the square root of both sides because I have to undo that square. Square root of cosine squared theta is cosine theta is equal to plus or minus square root of 5 over the square root of 9 is 3. Okay, so I know at this point, because I'm in that first quadrant, I know that cosine is positive because my x value is positive. So I'm going to rewrite this as cosine theta equals positive square root of 5 over 3. But I want to know secant. Let me just move this up one more time. All right, I know from my formulas that secant theta is equal to 1 over cosine theta. So I have secant theta equals 1 over cosine theta is equal to the square root of 5/3. So I'm just going to rewrite this. Secant theta equals, you're just going to do keep it, change it, flip it. Keep the one the same, change division to multiplication, flip your second one over and multiply 1 times 3 over square root of 5, which just gives me 3 over square root of 5. But I cannot have a square root in the denominator. So I have to multiply top and bottom by the square root of 5. Okay. So secant theta equals 3 times the square root of 5 is 3 square roots of 5 over square root of 5 times the square root of 5 is 5. Okay. All right, here's 2 problems for you to try. Go ahead and try them out, and when you're ready, I'll go through the answers with you. All right, the first one, cosine squared theta plus sine squared theta is equal to 1. I have square root of 3 over 3 squared plus sine squared theta is equal to 1. Square root of 3 squared is 3 over 3 squared is 9 plus sine squared theta equals 1. I'm going to subtract 3/9 on both sides. And I get sine squared theta is equal to 6/9. I have to take the square root of both sides, and I get sine theta equals positive or negative. Square root of 6 is less than the square root of 6 over square root of 9 is 3. And because this is in the first quadrant, I know that sine theta is positive. So sine theta equals positive square root of 6 over 3. All right, but I want to know cosecant. Cosecant gives me cosecant theta is equal to 1 over sine theta. Because I know what sine theta is. I have 1 over square root of 6 over 3. So when I do keep it, change it, flip it, I'm going to be flipping this over and multiplying it by 1. So it's just going to be 3 over square root of 6 because, well, when you multiply anything by 1, it's itself. I cannot have the square root in the denominator, so I'm going to multiply top and bottom by the square root of 6, which gives me 3 times the square root of 6, 3 square roots of 6. Square root of 6 times the square root of 6 is just 6. But I can reduce 3/6 to 1/2, which I can just write as square root of 6 over 2. Make sure you reduced. Okay, last one. We have, okay, I need to find cotangent theta. So cotangent theta is equal to 1 over tangent theta, which I know that tangent theta is just 2, so cotangent theta equals 1/2. That one was nice and easy. All right, let's try another one that's in a different quadrant. Okay, on this one, we have, this is going to be between 180 degrees theta and 270, or angle theta is between 280 degrees and 180 and 270 degrees. So if cosine theta equals 1/4, find sine theta. All right, for this one, I'm going to say cosine squared theta plus sine squared theta equals 1. Cosine theta is 1/4, so this is 1/4 squared, don't forget about the squared, plus sine squared theta equals 1. All right, 1 squared is 1, over 4 squared is 16, plus sine squared theta equals 1. I'm going to get sine by itself by subtracting 1/16 on both sides. I have sine squared theta is equal to 15/16. At this point, I need to take the square root of both sides. And big square roots undoing squaring. I have sine theta is equal to the square root of 15 over square root of 16 is 4. That's my answer. All right, so I want you to try one just like that. Oh wait, I forgot one step. It's positive or negative. I can't forget that. Okay, so in this quadrant, I have to think about, is sine positive or negative? So sine theta is negative, meaning my answer is negative square root of 15 over 4. So that's not my answer because it's either positive or negative, depending on which quadrant it's in. All right, this one's for you to try. Go ahead and try it out. I'll go through the answer with you when you're done. All right, we have tangent squared theta plus 1 is equal to secant squared theta. I know tangent theta is negative 3/5, but this has to be squared, plus 1 is equal to secant squared theta. All right, we're going to square it, so anything multiplied, a negative multiplied by itself is a positive. 3 squared is 9, over 5 squared is 25, plus 1 equals secant squared theta. All right, 9/25 plus 1 gives me 34/25. That equals secant squared theta. All right, so at this point, I want to take the square root of both sides. I'm going to move my problem up. Okay, so we have positive or negative. Square root of 34 is just the square root of 34 over 5 is equal to, secant theta. And I'm going to flip it around so that my secant theta is in front. All right, so if we look at secant theta has to do with cosine theta. So we need to figure out, is cosine theta in this quadrant positive or negative? It's negative. So I know that I have to take the negative. It was either going to be positive or negative. It's negative square root of 34 over 5.